Hello, how is everybody doing tonight? Welcome to SkyTour LiveStream, our second stream in a row from Arizona. And a meteor, not a meteor, but a satellite says hello to us right off the bat. We're going to see lots of those. We see lots and lots of satellites during the night. So you're going to see a lot of them tonight too, I can imagine. Welcome to SkyTour LiveStream. I want to thank you guys for showing up. We're going to have some fun tonight and look at objects. I'm actually in the middle of doing a identification here because my telescope seems to be a little bit off. So we're going to keep trying here and see if we can identify exactly where we are. And then yeah, see, we're having an issue there. It says not finding stars. I'm going to try reducing the sigma value. Okay, let's do that. I don't mind showing you people the workings behind the scenes. I don't have any problem with that. There's nothing to hide here. We also have some bad throughput tonight. It doesn't affect what the telescope actually sees and what actually gets sent up to the cloud. Because what gets sent up to the cloud is really stunning. And what you see on the screen could be the result of a slow internet. But not to worry. Okay, we're going to drop this value to 40. And let's see if it tells us a little bit better where we are.
Introduce me, Mark.
Oh, I am so sorry. I was so caught up in getting this done. As you can imagine, on our nightly forays, Daryl Mason's with me. Daryl, I am so sorry. I'm going to let you take over now.
You're busy. Hello, everybody.
Yeah, sorry, Daryl. I was just trying to figure this out. I'm going to reduce the sigma value by 10 points. I'm just trying to get the plate solved to do what it's supposed to do. And, you know, it does. It works. But we're also waiting for the camera to cool down. And we're waiting for the observatory to reach the ambient temperature. I opened the roof a little while ago. And it was 90 in there. So being that it was 90 in there, that's pretty warm. And so it takes time for the air to exchange with the outside. Okay. That's all right. We'll get that to work. All right. Well, anyway, let's take a look. Our temperature on the cooler is minus 6.3, which is about where it reaches when it's pretty warm in there. But we are accurate enough that I think we can move to some areas and find some things. So we're going to do that. But we're going to do this, we're going to do it manually tonight because I don't want a repeat of what happened last night. So first things first. I think we can go to Antares. Let's go over here to Antares. Because if we go to Antares and I get it in there, then we can use Antares as a marker and set up the telescope and get it positioned right. Let me just get rid of these lines here, and you're going to hear the voice of the computer announcing different events that are occurring as well. So that'll be happening as well. Okay, so let's up north a bit here. And I want to get over to Aunt Terry's, make sure that it's where we think it is. Okay, so now we're going to change this. Again, you see down here, this is the telescope control system down here. And we're setting the speed at which the telescope moves to be a little bit slower, now to 0.25 degrees per second, quarter of a degree per second. And then we're going to head west now. And I'm going to reduce the size of this window just a little bit. And pull it over here. Alright, so we'll be able to see Aunt Terry's when it comes up. Yeah, the internet's pretty slow out there right now, so let's see what happens. It could get better as the night goes on. Or it could grind to a halt, I don't know.
And Terry's is getting over there in the west pretty good already now.
Yeah, it sure is.
I know I'm a little bit ahead of you. We're both in mountain time, strictly speaking, but
Yeah, but you're still...
and Terry's is, gosh, it's going away like 10:30 at night now, I think.
Yeah. Well, it's low in your sky too.
Yeah.
It's a little lower. It's a little higher in this sky here. Oh, another satellite. So what we're hoping is that nothing happens like happened last night, because last night the telescope had a conniption fit for some reason. But I'm going out there, not next week, but the week after. And I'll be in the desert, and I'm going to be working on it to try and fix all that ails it.
Are you going to Arizona direct from Vegas?
I'm not going to Vegas.
I thought there was a convention there or something.
Yeah, the MUFON Symposium is going on now. I'm not going to that.
Oh.
Yeah. Let me just bring us up a little bit here. Okay. All right, now let's head to the west again. I wonder if that was it that just screamed by. Well, let me just go to the location that it's supposed to be in and see if that's where it is.
What? Thunder. You hear that?
No.
It's bad enough. I'll close the door.
Well, if you lose your power, I'll know. You just won't be there anymore.
Getting a nice cool breeze, though.
Okay.
I'll keep the door and window open as long as I can.
All right. Okay, so Aunt Terry's is supposed to be right around here. And I'm going to guess it's not there. Nope, it is there. How about that? All right, so we did a solution for the field earlier tonight actually, before we connected with you guys, and it was the telescope said, this telescope says 16 hours. These are our coordinates here. It's like the latitude and longitude of the Earth extended out into space. The right ascension lines are the longitude lines, and they're broken up not into 360 degrees of vertical like gores on a beach ball, but into hours, so 24 of those. And then the latitude lines are what we call declination. All right, and right now it says that we're at 16:31:29, so those are 16 hours, 31 minutes, 29 seconds of arc. And minus 26 degrees, 37 minutes, 20 or 33, 29, it varies, seconds.
Can you call up Stellarium again? And
I can, and that's what I'm going to do.
And center on Antares and see what it says the coordinates are.
Well, that's all I have to do is click on Antares over here
Well, yeah.
and see what we've got. So I'm going to do that and see what it is. Because I felt that we were right and that maybe the plate solving process was incorrect. And it could be, again, because of the fact that the telescope wasn't cool yet and the stars weren't bright enough in the sensor for this to happen. So we're over here. Just a sec. But I thought this might be working, so this is good news. Alright. So, that said, if we click on Antares, right, well, that's the scope. Let's get rid of that. It says 16 hours, 30 minutes, so it's looking like, we were correct, and that it plate solved incorrectly. And that's okay. So if I get Antares in here specifically, let's do this. I gotta get closer. I don't want to waste too much time because I want to get to the things that we want to show you tonight. But this is important to do right here. Okay, there's Antares, and it's showing at a right ascension of 16:29:24, and we're at 16:31:28. That's pretty close. And the declination should be minus 26 something. So the declination is minus 26.25. We're at minus 26.38. Okay, the telescope's aligned. Everything is fine. So we just have to make sure that the plate solver does its thing properly. We don't need it right now, but we got it. So now what we'll do is, actually, I'm going to come back here. I want to go racing up. The lines here and head up to the objects I'd like to take some imagery of tonight. And that takes us all the way up here. And we're going to just start bringing them up. But I'm going to go to the east first. And to do that, we're going to set our speed to the maximum speed, which I just did. And now we're maxed. And now I can go to the east. And you'll see the telescope, and right there, you'll see the telescope moving rapidly now. And it's going to head to the east now. There it goes. All right, and you'll see the target here doing the same. And of course, we've got we're right in the middle of the Milky Way here, so it's kind of fun to poke around there for a second. It's always fun. I love the Milky Way. Can't get enough of it. But again, I don't want to miss out on the things I want to show you tonight. So I'm going to resist the urge to go Milky Way spelunking, which is what I call it. So we're going to head east again and head up this way. And hopefully we'll have enough time. I suspect we will. Now we're going to go up. Head north. Okay. Alright, let's see this now. Okay, we're heading up to like the plus. We're going up here. We're going to the elephant's trunk. So that is a right ascension of 2056 and plus 47. So we're almost on the right line. So we're just going to go 2046. So I'm going to bring it up. And we just have to go up 40. So that's going to be kind of high. Alright. That's 27. So we're heading like into the north right now. The Great White North. We're almost there. Okay. Alright. And now we're going to head to east. All right. Now, the other night I was using the go-to function where I was actually just pointing it at the thing and telling it to go. But we actually had an issue, which I didn't count on, and that's why I'm doing it this way now. Alright, so let's get into this a little closer. Alright. Alright, so okay, to the east some more. We're going to that spot that's blinking over there. I'm really anxious to do this. I have not imaged the elephant's trunk from this location. And from this location here in Connecticut where I have light pollution, I was able to get it. And it was beautiful. Actually, that's the wrong guy. I really don't want that. I want this guy over here. That's where I want to go. Alright, so that's going to be 20 and 42. Okay. So let's go. And he's at a little higher. So we'll go up there. Well, that's pretty good. Alright, and now we run east a little bit. Run east a little more. Alright, and we're going to have to start slowing down our slewing a little bit as we get closer. So many stars out there. It's just beautiful. Alright. We're already into the nebulous detail here. I'm just trying to get us closer to the actual object that we're looking for. Alright. Alright, there we go. And now I'm gonna go and slow us down more. Let's go to, like, let's try this. Okay. A little south. I haven't had a chance to look over at the chat yet, guys, so bear with me on this.
We're talking eastern versus western mountains at the moment.
What do you mean?
Martian Johnson talking about mountains in New Hampshire, I guess, Mount Washington.
Oh, okay.
And, he asked me about Pikes Peak. And,
Martian Johansson?
Yeah.
Okay.
We're talking the Appalachians, I guess, or whatever.
Yep.
And
that's out here. Yeah. Okay, let's do this now. Make a run right into this object now. If you notice, the telescope is really pointing, pretty radically. As the night wears on, okay, if we didn't have a moon, we could just wait for this to come up more, but I want to look at it now. Let's see what we got. right, let's do more than a second exposure. Let's actually do a longer exposure here and see what we've got here. Let's do I'll do 15 seconds to begin with. And another satellite.
Yep.
So 15 seconds is starting now, and I gotta go to, I keep forgetting to go. I want that to be by default. The color space should be raw 16, and I don't like that it's not. I have to figure that out, make sure I do it, get it that way. Okay. So, 15-second exposure is being done now. Okay. We gotta drop that down. Let's live stack that. Well, actually, let's live stack this. I'm wondering if I'm getting the edge of the building in this. I could. Okay, we have one frame stacked. Let's get a second, and then we can start doing some processing. We have to wait for, but there's only 15 seconds. All right, we got 2. So let's try this. And then this. Okay. We're getting some. Look at that. That's beautiful.
Mm-hmm.
I think that's it right there. I think we have it right there. See it?
Mm-hmm.
Wow. Oh yeah, I'm telling you, that's just stunning. I'm going to change the exposure settings, so I'm going to pause this right now and clear this and change the exposure settings now and set it up to longer, because I'm only doing 15 seconds. I want to do more than that. And unfortunately, you don't get to see it. It's best because the I said 35. Because the machine is not moving fast enough through the internet here, so we have an internet slowdown out there. So we're working at it, doing our best to make it work. I should probably move to the right a little more, center it up. Yeah, that's it. Look at that. Okay, it's also quite a bit brighter than I want it to be. So let's see if we can back off on this guy.
Looks a little different than it did when we got it the other night, but you can still see both. You can still see both the elephant's trunk and the nebulosity over to the right of it.
Yeah. Let me I think I want to move the entire. See, that's it right there. That's the beginning of it. So what I want to do is I'm going to move the telescope a little bit to the east, and that'll change this whole thing, I'm sure. But let me just try that. And yeah, this is gonna be beautiful when it comes in. I gotta set our values here. I'm under the gun because I'm trying to get the beat the moon. That's what this is. It's the beat the moon stream. Okay, so this will go down to just being stars, and I'm gonna get rid of the stack for now. Get rid of this. All right, and I'm gonna move over. I have to pause it and clear it because this is just a stacked image. This is not the live view. The live view is back out here. This is our live view. All right. So now, let's see what we've got. It moved, and I didn't see where it moved to. I went the wrong way.
The other east.
Yeah, well, it's flipped over. That's the problem. It's flipped. That makes sense now. Now I understand why it was reacting that way. Okay, we'll center this up. There's a beautiful dark nebula up here that's going to be evident here shortly. Okay, and just a little bit more. Okay, and now we come out and get rid of this hyper process and bring up our live stack again after we set this to be 25 seconds. And the gain is 415. I'm going to change it to 400. And that could also be responsible for why the plate solve wasn't working. You know that?
How's that?
The gain was up at 415, which means it looked like it could be pretty noisy. So it might have confused that.
Okay.
All right, let's clear this. All right, and then come back here. And we got 25 milliseconds. I don't want that. I want 25 seconds. You fool! Okay, 25 seconds. All right, and now we're going to clear this one more time. And now we're cooking with gas. So once again, I want to welcome everybody here to the SkyTour LiveStream. I see Doll Eyes here, Martian Johansson. It's nice to see you. And the first person here was SA, Satisfying Animations. Great to have you here. Thank you. And we have C&D Boy. And C&D Boy, thank you for your wonderful compliments. It really is humbling to know that folks in Canada see me and watch me on the boob tube. That's nice. And I hope that that continues. Hi there, PG. I'll see you in a week or so in Pine Bush. Daisy and Zoe Amethyst. So nice to see you. And Lane is with you guys again. Hi, Lane. How are you? Lane is, of course, relative of Daisy and Zoe Amethyst. And it's so much fun to have you guys with me. And of course, Daryl. Mike C. Hi there, buddy. Nice to see you. Cypher 2. Another long-time viewer. Cypher 2 is good to see you. And Vera Lucia Campos from Brazil. Welcome to you. And I said hello to Martian already, and that's great. I'm glad you're here.
Isabella's here.
Is she? Okay, I haven't got to her yet. And I said hi to you, Dalai. How you doing? David Schmidt, good morning to you. How are things in Thailand? Really, really good to see you. And he's talking about, let me get to your question in a second there, David. That's a good question. And then Isabella Melamed from Bulgaria is with us. And we have Anahata77. Bonnie, how are you? It's nice to hear from you and see you out there. You guys are just amazing. And I know that, like I said, I didn't. I don't know if I'm going to hit everybody here, but I'm trying to. But it's great. I'm really happy to see you. And I want to go back to Dave's question. Are you able to go back to Dave's question while I work on this? Because I'm trying to just get a particular setup here, Daryl. Are you able to find David Schmidt's question?
Looking. Give me just a second.
Sure. Let's see if this is going to help us. That's interesting. Let me get rid of this guy and see what that does. Okay, that's like having a regular... That's like seeing it when we do it here, you know. But
I don't see a question from David Schmidt.
Yeah, he did. He's near the top. He's or up high. I apologize, David. I wanted to make sure I get back to your question. Some very good questions. Wow, look at this. Okay, we've stacked 7 elephants' trunks. Sorry to ask you to do that, Daryl. I'm trying to get to a certain point here.
Oh, that's fine. I don't see a question he asked.
Yeah, it's up there. Ah, look at this, guys. Talk about complexity. Look at the complexity of this dark nebula over here. All right, and then the complexity of this over here. I'm gonna pin this here so that it'll go away, and we'll see this larger. There's the elephant's trunk, guys, and it's a protrusion of gas and mostly dust. Okay, that has ionization going on. The colors are not correct. I'm gonna let me just try and correct the colors real fast here. And to do that, I'm going to try this right here. See if this will do it. Because right now it's not adjusted. That's a little better. Look at that. There's the Elephant's Trunk Nebula. It is just an amazing place, and it's really got a lot of material in it. And right now we've actually we've stacked 10 frames so far. We're gonna go, I think, to 25, and then we're gonna move over. We're gonna actually head eastward a little bit, and we're gonna pick up the Iris Nebula, which is gonna be interesting because I think the Iris is gonna take up some goodly amount of space here as well. But that's the elephant's trunk right here that you see right there, and that little protrusion, that little bulbous thing, and right inside that hole, there's a hole there, and I want to try and zoom in on that for you. And again, the telescope hasn't been fully collimated, unfortunately. That's going to happen again when I'm there next week or a week after. But I want to show you that hole because that represents a very interesting location. If you notice, there's 2 stars in the middle of that hole. Okay? And right there's 2 stars inside there, and it's actually a cavity. Remember what I talked about? When I talked about how hot young stars make a cavity around themselves where they clear dust and gas from around them, and then if they go supernova, that supernova material expands so fast that it actually reaches out to that cavity wall, which is the separation between that very, very, very thin, what we call rarefied atmosphere, basically inside that cavity, and then it reaches into the interstellar medium where it's more dense and knotty and non-homogeneous. Well, that's an example. It looks like a cavity of these 2 stars that are inside that cavity. I think that's pretty interesting because you can see the cavity in action right here, right there, right, that little guy right there. That's pretty cool. So that's all I wanted to say. So there. I think David might be restating his question.
Yeah, I didn't see it, and 2 other people didn't see it either.
Okay.
We were talking about the Pikes Peak Hill climb
Okay.
a little while back. Maybe you thought that was a question.
Okay, maybe I did. Sorry. Sorry. Look at this.
Sorry.
Isabella, can you see this, Isabella? Look at that. You're going to have a field day with that. This is a beautiful, beautiful elephant's trunk, and it just stands out like you can't believe.
Inky black to its upper left.
That's right. That's a beautiful dark nebula there.
Yeah, big black to the right.
This thing on the right, when I get out there, I'm going to check the dew shield because I think it might be aiming into the field a little bit and vignetting the field. So I have to recenter the dew shield because we did have a problem where the telescope did crash down, but the dew shield, being made of metal, protected the camera and the special lens on the end of the corrector plate, all the fragile parts, in other words. They were corrected. They were protected, I mean. So I think this is the result of having a dew cap that's slightly off kilter. But hey, you know what? We still get good photos. And once I collimate it, the stars are going to be absolute pinpoints. You know? So I'm really looking forward to that.
Dalai, it's red because it's hydrogen.
Oh, there we go.
And
good question.
the hydrogen is emitting characteristic wavelength of light.
Yes, we call it hydrogen alpha. That's 65, 63 angstroms, or 653 nanometers. Is that the wavelength? I can't believe I'm spacing on the wavelength.
Me too.
No, I know the wavelength. I can figure that out.
It's red, I know that.
Yeah. Yeah.
Kind of a pinkish red.
Yeah, it's depends on the number of atoms, right? Yeah, it's 65, 62. Okay, so actually, it is 656 nanometers.
I guess the question now would be, what's making it glow red?
Well,
Is it the bright star in the middle, or
oh,
is it where's the energy coming from that's making the hydrogen emission come out?
well, the interesting thing is, remember, space is 3D. I don't know that answer, but I can tell you that there may not be just one unique source. There could be multiple sources, which could account for the differences in intensities, right? The differences in the motions of some of these clouds, and you can see some beautiful. I mean, you can almost see the motions in these clouds now. It's really something. Gosh, it's really beautiful.
Yeah, I know in some cases, like North American, the pelican, I believe they say Deneb is energizing the hydrogen.
Yeah. And the way that works is really interesting, too, because here is the trunk itself, of the elephant's trunk itself. Let me just move it over so you can see it a little better. The elephant's trunk itself, okay, if you look at the red glow that you see permeating, mostly hydrogen gas in there. Now, you can't see hydrogen gas, of course, but when ultraviolet energy from hot young stars, such as, say, this star or this star possibly, or maybe even that little tiny star right there could even be doing it, but, because it's a three-dimensional universe, you don't know how far away it is, how hot it is yet. Okay, well, anyway, the stars energizing the nebula are not necessarily the biggest ones in the field. Well, anyway, what happens is hydrogen is a proton with an electron, okay, and the electron is in a cloud around the proton of the hydrogen atom. Well, when enough ultraviolet energy is captured by the electron, it gains energy and it goes higher and higher and higher in that orbit. It's a cloud, actually. And finally, it reaches a point where it's no longer bound to the hydrogen atom. That's when the hydrogen atom becomes something called an ion. And when the electron leaves the hydrogen atom, the atom is called an ionized atom. Now, also, the atom is sitting there. The proton is now sitting there, and the proton is undergoing collisions with other things out there, but the electron is also doing the same. And the electron can lose its energy very quickly. And what happens is the electron ends up spontaneously dropping back into a hydrogen atom, because you're going to find trillions of atoms. So when the electron leaves one atom, it may not come back to the same atom. It may never see it again. But it'll come down into the atom. And when we look at an atom and its energy levels inside, it has energy levels that are very discrete. They're discrete. You have energy level 2, 3,
Quanta.
4. Yes, and that's where the term quantum mechanics comes from, because there are discrete energy levels that are discrete quanta for each energy for each location that the electron can jump to. Now, the electrons, when they come back into the hydrogen atom, they're releasing energy to get back in. When they release energy, they release it in the form of light. Well, not all the electrons drop to the energy level that releases a red light. Some drop to another energy level, which releases a different kind of light. Okay? And so when we look at hydrogen alpha, it turns out, or clouds like this, it turns out that in space, in the near vacuum, in this rarefied gas location, where rarefied means very few atoms per cubic centimeter, it means that the electron is going to drop into the atom and go to one specific level more than any other Okay, so if you have a billion electrons, then almost 3/4 of those are going to go to the level called n equals 2. That's the number 2 level. So, and when it does that, to drop in there, it releases a characteristic light, a little tiny photon that's at 656 nanometers, or 6562 angstroms if you go back to how we used to measure it. And the angstrom, or the nanometer rather, that is distinctly red. Sorry, that energy level is distinctly red. So when it drops in, it gives off a beautiful red glow. And you can thank the beauty of what we see to a natural consequence of how electrons recombine with an atom. And in fact, they call the process of an electron being ionized and coming back into the atom, it's called recombination. Go figure. Okay? This is coming out gorgeous. Look at that. Never have I seen such detail. And we're zoomed in, actually. You know, we're not even at 100%. We can go even more. We actually go to 300%. And, you know, we're going to be digging into the pixels at that point, you see? But I did manage to get this focused as good as I can for a telescope that doesn't have the proper collimation, where the lens is a little bit off. I talked to Dean Koenig at Star Arizona, and we have a plan for getting this to be properly collimated very quickly. He knows exactly which direction it needs to go. I concurred. Ah, look at that. Holy cow. You know, here, the elephant's trunk, when you take it from here, it stands out because it's pretty much all you can see. But look, it's tied in with so much other stuff that you almost can't even see it. You know?
I have a question.
Yeah.
Relating to the hydrogen emission and which shell it returns to, and thus the wavelength, or which, you know, hydrogen we see, and that's hydrogen alpha, is the reddish light.
Yeah.
This may be beyond the scope of the stream, but I can think of several objects I have seen in the past. The Helix Nebula was one. Looking at the Horsehead Nebula in Orion was another one. And maybe there was a third one. Maybe it was Rosette Nebula. Hydrogen beta, not hydrogen alpha, but hydrogen beta filters were used to see all those.
That's correct.
Now, what I saw by eye was gray.
Yeah.
And, you know, if I looked at something in hydrogen alpha, of course, to the eye, and looking at astro images, or astro, you know, through the lens, would be gray also. But A, what color is hydrogen beta? And B, why a hydrogen beta filter instead of a hydrogen alpha filter?
Hydrogen beta is actually a less powerful line, has less energy in it. So the hydrogen beta line won't be as prevalent as a hydrogen alpha. Hydrogen alpha is by far the strongest line. Hydrogen beta is undoubtedly in this picture, but we don't see it as well because hydrogen alpha totally overwhelms it. And as far as its color, well, I mean, you just have to look at the wavelength of the hydrogen beta line. It's not really far from hydrogen alpha, so it's going to be in the same red end of the spectrum, but it's going to be a different frequency, a different value. Okay, so,
but if hydrogen alpha is prevalent, why use hydrogen beta filter?
I'm not sure what the difference between the hydrogen beta is. I know that hydrogen beta might be, in some situations, hydrogen beta might be the dominant line for certain phenomena, but I can't be sure of that. But I've heard of that too. I mean, it's like, you know, why do we use an oxygen 3 filter, right, for the turquoise view of the nebula, and a sulfur filter, okay, with a hydrogen alpha filter to do narrowband imaging, you know, so that's kind of weird, right? You don't really hear about sulfur, but there's plenty of it out there, you know.
No, and that's what they do with the Hubble palette.
Yeah, and actually
talked about before.
I would like to. I actually was gonna go down the path of doing narrowband 3 filter work What that means, folks, is you take a filter specifically for looking at this red gas. You take a filter specifically for looking at a bandpass that takes you into the oxygen 3 realm, which is the bluish turquoise, and you take a filter which takes you into another realm for the sulfur end, and you combine those three, and it gives you a very good picture of a nebula, because all three of those are prominent in a nebula. But by far, hydrogen alpha is the one that's dominant in most nebulae, and that's why people do that. And again, if you look at the hydrogen alpha line, it's at one end of that red end of the spectrum, and hydrogen beta is a little bit further away, but it's not as high a peak. It's actually a very small peak. I actually have a spectroscope back here that I use, and when you look at the hydrogen alpha line to the hydrogen beta, hydrogen alpha is way up here and hydrogen beta is down here, you know. So why would they use a different one? Well, that's if the hydrogen alpha line is you know, also being confused with other objects they're trying to look at, and hydrogen beta might be specific to the object they're looking at, and that might pull that out. And again, there's filters out there that look at a lot of different lines, very specific lines, all over the spectrum. So it's actually, you know, it's actually possible that we could look at that too.
Yeah, well, I know some elemental filters,
Yeah.
calcium lines, stuff like that they use in solar astronomy.
Yeah, and they would for that, because calcium is definitely an element that the sun was made with. The sun can't make calcium. And I think eventually we should talk about how the stars make elements, maybe on SkyTour Radio, on a radio show. You know, I think that'd be pretty cool. Hey, Tim F. You know, because we've talked about it a little bit, but you know, people look at a periodic table with 118 elements and they say, well, you know, the sun must make them because it's fusion. No, it doesn't. And even the biggest stars can't make them. So where do they all come from? And that's the whole point of the that's the whole point of it. You know, we don't have a way to accurately show that on a stream like this. We'd have to go through. Oh, look at this. We have to go through it with a little more, a little bit more. Okay, we went back. I knew that was coming. Sorry. We'd have to go back. We'd have to do it with a little more detail and a little bit more background. That's the problem.
Yeah, well, that might be a good show topic.
I think it would. Actually, it'd be a great topic for a SkyTour LiveStream if we want to do a interactive, basically astronomy class. I've been asked to do that, actually. And by KGRA, anyway. So we'll see. Okay, well, I saved the stack. Or did I? I think I saved the stack. While I was talking, I better have saved the stack. I must have saved. Yes, I did. I saved the stack. Okay, there it is. I'm just going to hit save anyway. Because that way, it'll be there twice maybe. But that's okay. Okay. And then I saved it exactly as seen. Okay, cool. So what we're going to do... Alright, I paused the stack right now, but I just want to show you just a little bit more, just to kind of look around this thing, because this is just beautiful. And then we'll move to the Iris Nebula. Let's go.
Oh, Iris.
Iris, yes.
You said that last night. I thought you said Irish.
Oh, well, you can talk. Well, we can go to the Iris Nebula if you like, but I'm not sure you're gonna like it. Look at that. Wow, look at that, guys. Look at that, huh? That is just stunning. And the colors, the rendering here is a little too intense. We have to tone this down to make it more accurate. Okay, we really do. If I wanted to, let me see if I can make that happen. So I'm going to go back to auto here. And then bring up the stack. God, that's beautiful. It's almost right, but not quite. And if I was to try and do an auto color. All right. Yeah, see, that's not right. It looks beautiful, but it's not right. God, that's pretty though. I will do the balanced color one for you when we get to it. All right, so let's clear this. The image and the stack has been saved out there, so you'll be able to catch it. Go up to the link, it'll probably be up there in just a few minutes. I hope you don't mind that. I mean, in fact, I hope you enjoy the fact that we actually do that now. We actually, everything, is available to you, and you don't need to be in Facebook to see it. If you don't have Facebook, you can just go to that link. And the link I should probably publish elsewhere, so you don't have to just see it in Facebook. I think I sent you the link, Daryl, right? If I didn't, I will send it to you. Then you can actually peruse all the images yourself if you like. But those are the ones that are processed in this camera. They're not the ones that I do final processing with, not yet.
I don't think you did.
Okay.
If you have one separate from Facebook, please, because I don't do Facebook.
I know you don't. Okay, let's head over now to the Iris Nebula. The Iris, it's over here, Captain. And by waiting a little bit, it's going to be up a little farther. There it is. It's even further north. That might be problematic. I'll try it because the telescope, because I have to wait for the Earth to rotate. The Iris might not be. It might be a little bit behind the wall of the observatory building, but we'll try it. It's not that far to go. It might actually have it covered. We'll see. All right. So 16 times. Let's go to a rate of 7. So now we're gonna go 1.5 degrees per second. So we head up. I'll make the screen update. It hasn't yet, so no worries. I have it on that 25-second thing. I'll be taking that off here shortly.
Oh, Joe, I saw that circle star formation you questioned. We've talked about this many times. Are those, when you see something like that, is it real or is it just a chance, superposition of stars against the background sky? Any particular case, I couldn't say. I would think if it was truly, if they were physically associated, you'd probably call it a cluster. We've often noted, though, like chains of stars in space, or chains of stars in the image, and
yes,
sometimes they might be real. We wondered about shock fronts in the Veiled Nebula and stuff, and other times there just happen to be chance alignments. Again, imagine you're sprinkling sugar on a black tablecloth, and it's the way they just fall. They're not really associated.
And I'll make that tablecloth 3D.
Yes.
Okay. We should now be just about there. We might luck out here. Give it a shot. Alright, let's go back here. Let's see. Let's bring this up and do a hyper process. There it is. Okay, now that we know where it is, let's bring it into our view. Oh, too far. So what I want to show you when I get it back here. This is something that we saw from here, but it wasn't very noticeable. But out here in this darkness, we might be able to show this in very rich detail. Especially after looking at how we did the row of Fuchsia clouds. It looks just like clouds of smoke. Well, this has clouds of smoke around it too. You can almost see it because it looks like it's blocking the stars in the back. You know, there's supposed to be more stars, but there's nothing here. You say, well, why? Because there's a nebula there. A dark cloud. I'm very excited to try this, and I'm hoping the moon isn't up yet. I think we have some time here.
I think you do. The moon isn't up here yet. And
good.
I'm farther east than you are,
Yeah.
so you've got a little time.
I think I have till 9:45 for the moon to come up here. All right, so let's. Oh, I didn't want to go that far. How come it did that? Okay. Oh, I know why it did that. The distance between the lines of longitude are much smaller than the distance between the lines of latitude when you get near the poles. So a north-south movement is going to be a drastic move as opposed to an east-west movement, which is going to be a very gentle move. But we're here now, so this is good. Okay, and it takes 11 seconds for the telescope guider to lock on. And that's going to be great. So now what I'm going to do is come in and take off this guy. We don't need all this extra hyper processing right now. And we're going to go to 25 seconds again. And then we're going to jump right in. It looks like the internet, by the way, has cleared up a bit out there now. This is good. And our camera's at minus 7.5 C, so minus 7.5 below, 7.3 below 0 Celsius. So that's pretty good. All right, and we're doing this. Let's see what our enhancements look like here.
The moon is up here. It rose at 10:04 p.m.
Okay.
And now I'll find where you are.
All right. Okay. I bet you it's going to be coming up. I thought it was 9:45, but I was just guesstimating based on looking at it below the horizon. It was 16 degrees below the horizon when we started, so maybe it's going to take a while. All right, let's go back to the histogram. All right, and let's see if we can get something here.
Time and date doesn't like your location.
Well, how about that?
So I'll check another one.
Oh, there we go. Wow. Let's see if we can that's not right.
Yes, 9:42 p.m.
Okay. This is coming out pretty. This is 4 frames stacked. And when we zoomed into the elephant's trunk, you notice there was no noise. If I zoom in here, you're going to see noise. You're going to go, what? What's going on? Why is there so much noise? And it comes down to the fact that we're looking at only 4 stacked frames, right? And when you have only 4 stacked frames, well, unfortunately, that means you're going to have some serious noise that's still in there, because the noise has to be averaged out over time. So you can see here we have some noise in here, but look at how beautiful that looks.
That's cool.
Yeah.
Is that a planetary?
No, this is actually a reflection nebula.
Oh, okay.
Yeah. I was about to describe this for everybody so they know what they're looking at too, because it's kind of cool. And again, we're getting you see some modeling. That's due to the nature of the internet connection. But this is a reflection nebula. There's a star in here, and what we're seeing here is dust, not gas. You can't reflect light off of gas. You can only reflect light off of dust. So we're seeing a star that's surrounded by dust. You'll notice the dust has a brownish look to it. Okay? It's real. That's how that looks. So this is very, very, very good. I've never seen it like this, and this is really exciting. Alright, so I'm going to drop down to 40% now. Yeah, look at that. You can see the brown dust. Oh, look at that. Now you can actually see what I was talking about. This is dust that is blocking the stars behind it. Do you see it? So it's a little knot of dust that's being illuminated by the star. Look at the little hole here where you can actually see through it. Isn't that cool? You see the stars behind it. That's kind of neat. You know? That's this right here. See this little tiny hole in it right there? That hole is actually allowing, you can see the stars through there, and this gas, this dust is actually reflecting the starlight. And these are actually, they call them reflection nebulae, but there's, and yes, you're getting reflection off of dust, but there's a little more to it than that. And we'll describe that at a future time, but it has to do with scattering, a process called scattering, Rayleigh scattering, Rayleigh scattering. The reason why the sky's blue is why these nebulae look blue. Same type of reasoning. So it's kind of cool to look at this. And now we've got 10 frames stacked, and if we just go to 100% size of the frame, this will show us what we have for noise. As you can see, you still have some color modeling in here. And I remove that in post-production anyway, but that's okay. This is beautiful, isn't it?
It is.
It's a beautiful nebula. This is what I wanted to do. I wanted to check these out. And at 11 frames now, we might get to the point where I can go to the cocoon after this, which is the next target. But look at that. You can see the brown dust. Look at that. It's just obvious. There is a color to the dust. Here's another thing, too. Have any of you actually read papers and looked at the data on what space smells like? What does this dust smell like? We do have an idea.
Gunpowder, doesn't it?
Yeah, it smells sort of like gunpowder. At least there's a metallic taste, and it smells like gunpowder. Wow. Let me see. I'm gonna mess with it a little bit, but don't worry, the stack won't be affected.
I seem to remember the Apollo astronauts described the smell of the moon dust when they were in the lunar lander as gunpowdery.
Yeah, yeah, yeah. One of them, some of them said it was sort of metallic, and others said kind of gunpowder. Look at this, right? I gotta show you. Look at this right here. This is really neat. I want to zoom in on that. I gotta show you this. It's an isolated dust blob that's actually go to 75%. An isolated dust blob. When we get our full speed, Starlink out here, this is going to be instantaneous, as if you're just scrolling in front of you on the computer. So right now there's a 1 second delay on everything I do, and it really is really, really difficult to deal with. Look at that. Wow. So you see this beautiful dust cloud that's actually sitting there, sort of separated from the rest, and when we process this, you're gonna see it just like it's supposed to be, and it's gonna be really pretty. These look like, they'll be separate from the rest of the clouds around them, and that's what's really cool. Yeah, this is something else. We've done 17 frames so far at 25 seconds. Now, I picked 25 seconds because if I went longer than that, the center of this nebula would be blown out. And I don't want that to happen for this nebula. It's better to go more frames at a lower exposure and then try to pull that data out, rather than to just go long exposure, which blows out all this. Oh, you'll see these out here, just beautiful. But a long exposure will blow this nebula out. But look at how beautiful it is in that nebula. It's a gorgeous nebula in there. Let's go back to just this. Okay.
All I asked if these dust clouds move. I would certainly imagine they do.
They do, yeah.
If that star is actually in the center of that dust cloud, the stellar winds would be blowing the dust away, if nothing else.
Yep, that is correct. But don't forget, the star is orbiting the galaxy. The dust cloud is also attracted to the star and also being pushed away by the star. So as it's being pushed away, as the star keeps rotating or going around the galaxy, the dust cloud tends to come along with it, and then might get ripped apart and torn apart and spread throughout the interstellar medium by other stars. It's going to encounter many, many millions of stars in its circulation around the galaxy. And I know you know the answer to this, Daryl, but for you guys out there listening, our sun, and there's a kind of a debate as far as how far out from the galaxy center our sun is. They used to say 30,000 light years, and they say, well, only 20, and there's a debate. We're in the forest, we can't see out through the trees, but one of the things that's really interesting is that when we look at how long it took our sun to go around the galaxy, okay, consider that we've already done it 19 and a half times. We've gone around the galaxy center, orbited the galaxy 19 and a half times since the 4.6 billion year birthing moment of our planet. Isn't that crazy?
Makes sense.
No.
I'm curious about there's a very red object, excuse me, to the upper left of the nebula.
This guy?
At about 10 o'clock, yes. Now, is that a dust cloud around it, or is that...
I think it's a halo.
The halo from the scope?
Yeah, you know what? I'm going to try... let me see if I can do a plate solve while I'm stacking this. I don't know if I can, but we'll find out. Okay, so it's just using a snapshot from here. Look at see how the dust clouds are becoming more refined and more visible?
Yeah.
It's just beautiful. Wow. I know it seems sort of easy to do this, but I tell you, there was a lot of technology that was brought to bear to get this to happen. And of course, to be doing it from... oh, there we go, we got it. So I'm going to copy this. to be doing this from a continent, the whole continent across the continent away, is another major, I think, beautiful thing. Okay. Yeah. Well, see, I think that. Okay, I have a image here that shows. Let me just bring this up. Okay, this is kind of what I see. That plate solve I just did shows us right ascension 20 hours 59 minutes 51 seconds, and declination 68:05:42. Well, 20 59 51, 20 55 16, and 68:01:14 as opposed to 68:05:42. So that we're actually pretty well aligned, is what I'm trying to tell you here. Okay, so we're good.
You're off 4 or 5 minutes in right ascension. That's horseshoes and hand grenades kind of thing.
Yeah, but when you have an f2 telescope, it almost doesn't matter.
Oh, right.
We have a field of view that's over 2 degrees across.
Excuse me for a moment, please.
I'll see you when you get back. Hi, Amanda Shaw. How are you? No, it's not. Sorry, I'm sorry you're 4 minutes behind. Hey, Rascally Rabbit. It's not gunpowder, but it just smells like gunpowder. There's no danger of the moon going off like a bullet. There's no doubt about that. But that's actually a very good question, because if it smells like gunpowder, is it? Well, the answer is no, because there's, you can smell sulfur. Sulfur is a main component in the universe too, right? Not nearly as prevalent as hydrogen, helium, carbon, nitrogen, oxygen, but it is there. And as such, it's got a very pungent smell and would lend itself to that. Think about the birth of the Earth, and the volcanic activity we have here. We have lots and lots of sulfur deposits on the planet, right? So that's something that is really, it's part of our planet's history and geology. So that this element has been made in a lot of stars, right? And when you look at the periodic table, and God, I just can't get over how beautiful this is. When you look at the periodic table, and you figure out you figure out just how much was involved in making that periodic table populated with the elements we see, and this is just the elements we see in our crust, right, and in our air. This isn't. These aren't elements that we made some elements, but this isn't something where we actually just made all these elements up. These are real elements, real materials that were forged in the hearts of stars, either through supernovae, through a process called the slow process, which is a process like the sun does, that makes the many different elements throughout the periodic table, and elements like gold, which we find from merging neutron stars. And in fact, nearly all the gold comes from merging neutron stars. Isn't that crazy? 2 neutron stars going around each other, and boom, they collide. Boom, big explosion, and gold is made, scattered to the interstellar medium. So I guess that means that gold is rare in the universe as well. So it's not just on the Earth where it might be rare, in a rare metal. I'm gonna actually check it out. We've got 36 frames stacked here while we're talking. I'm gonna just drop this green down just a tad and see if this. Yes. Haha. See, I knew it. Look at that. Look at this. Look at these clouds. Okay, we're gonna pause this now. And alright, now I'm gonna save this stack. Oh yes, I am. Wow. See, when I took pictures of this here, okay, we got the blue section, and we got hints that there was something else out here. We never saw this separation between the stars and these clouds. We never, ever saw that. This is really astonishing. I'm glad you guys can be here with me for this. This is gorgeous. All right, let's save it exactly as seen. And you'll see that. All right, so this image you see right in front of you will be available up on the cloud in just a few minutes. Amanda is a South Park fan.
I ain't fat, I'm big boned.
Okay, I gotta clear this. I don't want to clear it, but I'm gonna clear it because these pictures are now available up there. But I want to look at it one more time. I just gotta see. Let's do this. Let's just make this a manual process. We just go right in and zoom in. Look at that. Look at that. Wow.
That's really something.
Look at this beautiful little keyhole and the stars behind. Isn't that stunning? And we're like literally seeing right through a little hole in this nebula. That's beautiful. I actually wasn't sure if I'd get to see this brownish color. But this dust is effectively like soot, you know, so it's more black in general. But you'll notice as we zoom out that the brown seems to go down here too. It goes quite a further distance down. And then we have that isolated cloud over here, which is really very interesting. Man, this is going to be so much fun to do further processing on, I can tell you that. And right now Isabella's going, yeah. Because she likes it too. Okay. Now that we're done with this, I'm going to just do the clear, which I don't want to do, but I'm going to do it. I'll save it again. No, I won't, because I did 37 frames. That's quite a lot of frames. Alright, and I already saved it also. Okay. Now, let's go do a similar thing, if we can, for the Cocoon Nebula. And that will round out our series of 3 that I want to do for tonight. I just hope the cocoon... Actually, the cocoon should be a little better. The iris was not in the way of the wall of the dome. We actually had the walls of buildings, so we're fine. So let me find the cocoon. It should be over here. So it's substantially south, and that's going to be better for us. Oh, let me also come over here, and you'll see the telescope goes squirreling away. Just a minute. It's a 25-second shot. Let's go to 1 second again. That's what I thought it did. Okay, 1 second shot. And we'll do the hyper process. Just to be able to see what's going on. That's our live view. Okay, and now we'll bring this up. And we're going to go to the cocoon. Alright, and let me see what we've got for a speed on the system right now. 1.5 degrees per second. Let's go up to a little bit faster. Let's get to this setting, and now let's try going down. Alright. Down again. Okay, one more time. Alright. And now we start heading to the east. There's so much going on because we are in the Milky Way right now. We're just in the the other arm of the Milky Way that we don't see when we're looking at the Sagittarius arm, when we're looking down there.
There's M39 right there that we were wondering about last night.
That's correct. That's right. And we're zipping by it right now. You'll notice that the scope is following these lines. That's because these are the latitude lines of the Earth and the longitude lines of the Earth extended out into space. That's the right ascension, which are these lines, given in hours, and the declination, which is the latitude, given in degrees. Almost just like the Earth. We do it here. Okay, so now we are getting to the cocoon.
Deep Sky Clock event.
Okay. And now I'm going to drop us down and then change our speed to slower. We'll go down to 1/4 degree per second. And now we just can zip over slower and pull in as we reduce our speed as we move into this star system. Kind of like a spacecraft, isn't it? It is. There's a little nebula right there. It's not the one we seek, though.
Rascally Rabbit makes me think, he's mentioned black holes. And since we're in Cygnus, is there anything to be seen at Cygnus X1?
No. I don't think we see anything, not with our telescope. The Event Horizon telescope could certainly pull off a beautiful view of that, though. You know? That's definitely something that would be a wonderful idea. Let's go see if the cocoon is in here. It's got to be nearby. There it is. Is that it? Maybe that is it.
I think that's it right there.
Yeah, I think that is
Right
it.
at center.
Yeah. Okay, let's bring it down. Flick that bick.
So sue me.
Alright, let's see what happens here.
Have you heard about the new Japanese Jewish restaurant in town?
He just gave away the punchline.
Yeah, I did.
I'm learning Japanese. Be careful. Not very good at it yet. You really need to be immersed in a language to know it well, to get into it.
Oh, yeah.
That total immersion is the only way to learn. I did
Yep.
that. I did that with Spanish, Ahora yo hablo español también. Y inglés también. But not very well. I just do.
I was in Germany for 3 weeks back in 1990, attending a factory trade school.
Yeah.
And I just, at the 3-week point, I just felt like I was really starting to get the hang of it.
I'll bet, because you start to feel like, hey, man, I'm starting to figure out what they're saying.
Yeah.
Yeah.
At the same time, though, I know I was over there with a couple of co-workers. We were attending a huge factory school.
Okay.
Near Frankfurt, and we went out to dinner one night. We were staying at a hotel in a small town outside Frankfurt, and we walked a couple blocks away.
Yeah.
And wound up in an Italian restaurant in Germany.
Wow.
And there are a ton of Italian restaurants in Germany. But anyway, I tried to order in German. And the waiter was this big, tall, kind of dark-complected fella, skinny. He looked like he was from India. And I tried to order in German. And he was very patient. And finally he goes, in perfect Oxford English, he goes, "Pardon me, sir, do you speak English?" So I ordered it English instead.
That's very funny. Okay, let's yeah, see, we're gonna have some detail in there. Let's get rid of that.
My first boss at my last job,
Yeah.
he was a native of Austria, and he lived here in the States.
Okay.
Uh, and we had two technicians in from Germany one time, and they were hanging out together a lot while they were in town. And they were in the office one day, and I was in there, and I was listening to them, you know, and they were speaking this real clanking German. And I thought, golly, you know, that sounds really heavy. And they were going back and forth really fast, and
Clanky.
then I heard them.
Clanky is the term.
I'm sorry.
Clanky is the term.
Sure, why not?
Yeah.
One of them said, "Pizza und spaghetti." They were talking about, you know, where they wanted to go for lunch.
Wow. All right, so this is the Cocoon Nebula, and it's called a cocoon because it is a dark nebula that goes all the way out to here, right? And there's a star inside that when it was born, and it's a beautiful round thing. So the interstellar medium is sort of relatively evenly distributed at this location. So it's made a spherical, basically, cavity around it of ionized hydrogen gas. In some places where there's strong stellar winds, they might be dragged out, like in the elephant's trunk, where you see some of the hydrogen alpha region. But here, it's a simple little nebula that is a cocoon for young stars. And it's really pretty.
It is.
It's part of the northern Milky Way, so that hence all these stars. And just a little something for you to think about. When you see all these stars and all the pictures that we've taken here, there are more planets than any of those stars, and more planets than all the stars in the universe right now. Actually, that's our firm belief in astronomy, is that there's more planets than stars in the universe. And if you look carefully in this image, you can see, like, right over here, you see this little red star. Over there, you see a red star. There's a red one over there, red one over there, red one over there. Everywhere you look, you see red stars. Okay? Everywhere you look. Now, those are M-class dwarfs, most likely. And they are the smallest, longest-lived stars in the universe. They are only sometimes a little larger than Jupiter. Some of them are actually smaller than Jupiter, believe it or not. And they're just more dense, so they have to have 80 times the mass of Jupiter to be a star. And they actually do have 80 and 90 times the mass of Jupiter, okay? And our stars sometimes smaller than Jupiter. But if they're bigger, then that's okay too. But the thing is, those red stars are the most plentiful star in the entire universe. There's more of them than any other kind. And they have more planets than any other type of star. We found red little dwarfs like this that have 7 planets orbiting, three of which could be in the habitable zone for that star. And it's like every one of them is inside the orbit of Mercury from that star. All right. And because the star is so small, just a fraction of the size of the sun and mass of the sun, that it actually would take, you can actually take a year's vacation on one of those planets, and it would take you, for their year, time to go around their star, at most about 12 days, maybe 13 days, for a year. So think about the tourist trade. Now, how about that, huh? You think about the tourist. You're going to go to a red dwarf star, and the other thing about them is the planets around the red dwarf, they're tidally locked. So the same face always faces the star. You know what that's for? You know what's good about that? Astronomers can always go to the dark side and see a different night sky every night. Okay, as it's going around the star, it's facing everything else. And also, on the sunset side, you can see beautiful sunsets and go to your sunset paradise every single day, if you call it a day, right? It's every single dusk. It's permadusk. Hey, I just made that up. And then on the other side, facing the star, you have the beachgoers who are going to go out there and spend the time on the beach 7 days in the sun. You know, actually, a year in the sun, possibly, depending on where you are on the planet. It might be, I'll say, 11 days to go around the star. If you take a 10-day vacation, you can say, I'm going to this star for a year. Well, its year, okay, for this planet. Next thing you know, you're on your way to enjoy yourself around a beautiful star with a beautiful planet. And that's the kind of thing that would be kind of fun, too. You know? Martian makes a good point. We talked about the red dwarfs as being the most populous star in the universe, and they are somewhat temperamental. That is correct. But here's something for you that you probably haven't thought about. We just live with it because we know this from our history and from our biology studies and so forth. But you realize that we have evolution on this planet. What is evolution? Evolution, in short, is a phrase. You can say it's mutation followed by adaptation. Okay, so the DNA mutates, and then if it's something that can is a better survival characteristic, then that species with that new mutation will survive and reproduce lots and lots of itself. Okay, that's how come Neanderthal died, in part because a mutation led to further humans, like Cro-Magnon and beyond, to Homo sapiens sapiens, which is us, and the Neanderthals could not compete, and eventually they intermixed and so forth, and they ended up getting diluted down to nothing, and effectively were gone. They weren't just like, oh, we're dying, and they like just died, and that was it. That's not how it worked. Okay, but so evolution on this planet is mutation followed by adaptation. Well, how's the mutation occur? Now, Martian makes that point about the stars that are temperamental. They have ultraviolet flare stars that are red dwarfs. Many of them are. And you would say, wow, well, that ultraviolet radiation could kill anything on those planets then because they're so close. True enough. However, you look at all the mutations and changes in evolution that were caused by potentially the same thing here on our planet. And you say, maybe a red dwarf star that gives off ultraviolet radiation like our sun has and still does could also induce mutations in its life forms. See, I believe it's the ultraviolet radiation that is causing the cells to be changed on life forms here. There's a natural process too, that is built in. It's sort of like a serendipitous roll of the dice, roll the genetic dice. But the truth is, it's probably ultraviolet radiation at the heart of it, right from the very beginning. It attacks the cells, and it can disrupt the cells, and it can change the DNA. And if it does, well, then maybe that's why evolution exists on this planet. Okay, maybe that's why we have natural selection, because the ultraviolet radiation has made the mutations occur. And Martian, to your point, the ultraviolet radiation could be making the mutations occur, say, on a planet around a red dwarf star. And if the atmosphere is thick enough and they have a magnetic field, then maybe they'd be protected enough so they could grow, survive, and maybe their evolutionary trees make ours look like amateur hour, because they might have more ultraviolet radiation. So maybe they have a far richer, broader, diverse line of life forms in their tree of evolution. So I look at it as a possibility, and I think it's a good possibility. So kind of a little tirade there, I apologize, but I just wanted to mention that because I think that it's something that needs to be considered. Yes, the Martian mentions how the stars are various sizes. It's very hard to comprehend how big the sun is. Yet the sun is kind of small as stars go. In fact, all the stars that are fusing hydrogen into helium in their cores are called dwarfs. And they're type 5 stars. That's a V, Roman numeral 5. And when you get numbers that are lower than that, okay, the 4s, the 3s, Roman numeral 3, Roman numeral 2, Roman numeral 1, 1A, 1B, okay, now you're talking about giant stars and supergiant stars. Antares, which we saw earlier tonight, that's one of the first things we saw. Antares is a supergiant, okay? Antares will go supernova eventually. Betelgeuse is a supergiant. Betelgeuse is the red star in the upper left of Orion. And it used to be a bright, hot blue star. And 4.1 million years ago, when Lucy, Australopithecus afarensis, was roaming Olduvai Gorge in Africa, if Lucy managed to look up at the sky and could see the stars, Lucy would have noticed that Orion was made up of different stars than it is today, because some of the stars that we see today did not exist when Lucy looked up at it. And Betelgeuse was hot and blue when Lucy saw it. Betelgeuse has since become a red supergiant. So, there you go. I'll stop talking now. I'm not asking you to comprehend them, because even astronomers, okay, can't comprehend them. I do want to make a note, by the way, of this picture. You'll notice that in this Cocoon Nebula, you'll notice that the dust is similarly brownish. Okay? And it takes more images to stack so that it goes from looking just black to being brownish. And right now we have 31 stacked. That's pretty good. Isn't this pretty, Daryl?
Sure.
Yeah. Sorry, David Schmidt, that was you that was talking about the stars being different sizes. I apologize.
I saw an article a day or two ago. Who are the other
Homo habilis, Homo erectus.
No, the Denisovans, however they say it.
Oh yeah, is it Homo habilis?
No, specifically the Denisovans. Nowadays they talk about, well, there's Homo sapiens and there was Neanderthal,
Yeah.
and there were the Denisovans, and that they were interbreeding.
Yeah.
And this article was specifically about, I forget where, it was over in East Asia someplace, or Southeast Asia, or Philippines, or Borneo, or someplace like that, that they were seeing really strong indications that Denisovans and Homo sapiens, I guess Homo sapiens had been interbreeding a lot, and elsewhere they had found the same with man, Homo sapiens, and Neanderthal.
Yeah.
Then I guess the Neanderthals and the Denisovans are going at it also.
Yeah.
You talk about mutation and all that stuff.
There's a lot of that going on, right?
And the gene pool.
Yeah.
I can make an arch comment about men and where they stick things, but I won't.
You just did indirectly.
Yeah, I guess I did, didn't I?
Okay, I'm
But
gonna.
if you ever read the old book Clan of the Cave Bear by Jean Owl,
Mm-hmm.
she talked about this,
Yeah.
and it's really nothing new.
Mm-hmm.
Some people think that the Neanderthals and the Denisovans got bred out of us a long time ago, but they're still around. And
Well,
I mean, I worked with a guy from Buffalo, New York, and that guy, he was a Neanderthal, I would swear, just looking at him. You know, he had really heavy features and big beetling brow and all that stuff.
well, see, that's the myth, okay? That Neanderthal actually is gone. My nephew got his DNA checked, and I told him not to tell anybody the results, but he was actually 2% Neanderthal. He'd never hear the end of it if he told his friends.
I believe it.
And he's tall and has large features like that. I mean, he doesn't look like a Neanderthal, but he does have larger bone structure and so forth. You know? So I think that's pretty cool. You know?
I saw a Neanderthal here in town once riding a bicycle,
I bet you did.
and he had bright red hair.
I bet he did. Wow. Well, we got enough of these frames here. This is 37 frames, and we can see the brownish color that it does. I want to see the Neanderthal with bright red hair.
Oh, did you ever see the movie Quest for Fire?
Maybe. That was a long time ago.
Yeah, that was the one with Tommy Chong's daughter, Ray Dawn Chong. She played the girl from another tribe.
Oh yeah, man, that was funny, man.
They went out. They lost their fire. These cavemen did, and they had to go find more. They went and looking for fire, and they met another tribe, and the medicine man, whoever, knew how to make fire, and it just blew their minds when he made fire in front of them. Some people called the movie something else, Quest for something else, but I'm not going to. I've already gone too deep down that hole.
I think you probably have. Fantastic. All right, I think we actually satisfied everything we wanted to do tonight, guys. We managed to find all three of the objects that we wanted to look at and capture. And I'm trying to stick to my stream lengths to try and keep them just a little bit shorter. There is, again, just one more, I know. But there's something else that I want to look for, okay? I don't think we can see it quite well yet, and I think I just want to try and get an image of it. Oh, it's 25 degrees. It's not high enough. The helix.
Isosceles.
Yeah, I want to try and see, but let's go find the moon first. Make sure the moon is. What the heck? Thank you. Southeast. Okay, let's go to the east. Zoom out a little bit. Just make it simple. Alright, so let's get rid of the... Yeah, the moon's up already. Okay, the helix will be too close to the moon. But, over the next couple nights it may not be, and we're going to go for the helix as well. I would like to see... I would actually like to see just how the helix would look in this telescope, though. So I might just try to go to the helix and get a shot of it anyway, just to get an idea.
Sure, give it a go.
Why not, right? Doesn't matter. Let's do full speed here. We should be set. Alright, so let's go now. Let's go here. should be right here, right? Yeah. Well, we're almost at it, so geez, why don't we just look at it and see what we got, huh? The trouble is, we might be a little close to the wall of the observatory here, but you know what? I just doing a test. I want to see what we got. I want to see if it's something that would actually be visible. So I like the idea of trying to look for it. And let's go back over here right now and bring up our camera, and let's just actually do some hyper process here just to see it. See a little glow. I think we got the building here, but you know what? I just want to see. I just want to see it and see what it looks like in this camera. It won't be perfect. It won't be something we can work with right now. We have to wait for the moon to go away, and of course, as it comes up, it's going to get higher in the sky by far. All right. So we've got the building in the way a little bit, but I just want to see it. Yeah, we got the building's way in the way there. Okay. I might have too much of the roof in the way. I think I do. I might not even be able to see it. We'll find out. We'll find out, won't we? So we're going to go down to making a slower rate. It's a 16x. And now when I drop us down, I just want to get a glimpse. I don't know if we'll see it, but we'll find out. Okay. So it should be in here off to one side. It's going to be very dim if it is. Yeah. You see the screen turned white? The last person in the building left the screen on. And so this screen is white, and therefore the camera sees the wall of the building, and of course it gets white. You know? That's kind of, you know, my fault. I think we have something right here, though. I see something here. That's okay. As it rises higher, we'd get to see it, but the moonlight is too bright on top of it. So a couple more nights, let the moon get a little farther away as it circles around the Earth, and we'll be fine. We'll be just fine. So right now, let me grab our view and just increase the size enough to kind of catch what's going on. All right. Okay, let's go west now. Actually, and I will park us now. I shouldn't have a problem parking. Don't think I have a problem parking. That is our park position. And it says slewing. And it'll say turn the scope off. The scope has been parked. Okay, so we know we can turn it off, but before we disconnect power, I'm going to disconnect the scope entirely here and close gracefully. We're upgrading some software. I think I'm going to move to a different control program system for this whole telescope, and that will be something that I will be implementing. Probably not this trip, but I will have other people implement it. I can actually do it remotely. Okay, implemented some of the other stuff we did remotely as well. Okay, so now our telescope is actually in the park position. See, here that's where it's looking at right now, and it's, if we click on that crosshair, we'll see where it is. It's actually it's looking at plus 34 in right ascension and declination. But if we had just a dome over our head of sky and we just said what angle is that in the sky up from the horizon, well, we're looking right now at just over 30 degrees right now. The entire telescope's getting raised 6 inches so that we can actually start to look farther down in the southern sky a little bit. That's another thing that we're going to be doing. Alright, so for now, this guy is done. You'll notice that the stars are moving right now. You know what you're looking at? You're actually looking at the Earth rotating, because the telescope is now parked, meaning that it's still looking out and it's still active. However, it's just looking at the sky, and as the Earth rotates, we're watching the Earth rotate out from under the stars, because we're at a fixed point on the Earth. Isn't that cool? So that's what's happening here. You know, you could literally sit here and watch the sky roll through all night long. You know, it's really kind of cool. Which we're not going to do, of course, but, you know. Alright. Okay. Now I will disconnect the camera. Good night, ZWO. And let's get rid of the camera application. And I can check the temperature inside the dome now. I keep calling it a dome, inside the building. So if you go to temperature, it's 90.3 in there right now. At at 10:15 at night, it's 90.3 inside the building. So see, it's still pretty warm out there. And that explains why we couldn't reach the minus 10 degrees Celsius on the thermoelectric cooler with the camera. And that's okay. We didn't need anything. And luckily, I have the telescope focused for 90 degrees, you know, in temperature. All right, so that's done. So we are at the point now where all we have to do is shut off the power of the scope. And when I shut off the power of the scope, you'll see that the handset is going to go off over there. And there it goes, it's off. And then we shut the roof and button her up for the night. And here comes the roof. Good night, SkyTour LiveStream West. You gave us a beautiful night once again. From 2,500 miles away, you performed beautifully tonight. And to all of you that are listening and watching, I hope you actually have a good evening. Now, if you have any questions, you can ask them right now. Martian has a question. How are you cooling the sensor? It's a thermoelectric cooler called a Peltier cooler. on the camera, and it electronically cools the sensor down to -10 below 0 Celsius. There's a practical limit to those sensors, that cooling. So we know that practical limit can be reached. Our telescope, when it's 90 or plus 90, it's been 110 in that building before, and we can't cool the sensor down beyond -6 when it's like 100 degrees in there. So there are some pretty big limitations on these things. But that said, I don't think that this telescope here is going to go anywhere anytime soon. We're actually having a good time with it. We do have room for 3 peers in here. We're going to put another telescope in here from another streaming bunch of guys. I'll put that telescope in for them. Then they'll be able to operate it. But we're not going to do it until Starlink is here, so that everybody has bandwidth that they need. Let me just mention, let's talk about this. You're seeing the picture, you're seeing me, okay? I'm broadcasting this framework, everything you're seeing. I'm broadcasting, okay, me here, okay? But everything else on the screen here, all this is coming from out in Arizona in the desert. Okay, this is the Arizona computer you're looking at right here. Okay, everything is there. Everything you saw on the screen is in Arizona on that machine. And I'm using that machine as if I'm sitting in front of it. Okay, and so I add things on top, like our logo up here, the SkyTour LiveStream, the logo over here, and the time and so forth, and me down here. I'm doing this from Connecticut, so I throw that layer on top of all this other stuff you see here. So all that stuff you see is out in Arizona, and I'm throwing myself on top of it, and that way I interact with you this way. And of course I have the music that you hear, which is in the background, and the music is, I got a varied supply. Very nice music, actually. It's a lot of fun. And then of course I have another channel where Daryl's on with me, and Daryl's on through Skype, and I have Skype piped in, and so we're doing it that way. So it's really not it's gonna sound crazy to say this, it's really not that complicated, but everything I'm using to do this, everything is free software. All right, the only software I pay for is a software to get the screen out here in the observatory. This program I use out here is different. So one thing that I thought might be cool is I've been working on the North American Nebula, and in my image processing system, okay, this is what that looks like. Here's the North American Nebula right now, as I've been processing it. All right, you don't need me so big in the screen here, but if you notice this stuff right here, this is beautiful, beautiful stuff. And over here in Photoshop, these things are called actions, and I've written a lot of actions to actually, in fact, everything from here down, these are what are called actions that I wrote that will do certain things. Like I can go and get every single star image in here and reduce its brightness a little bit to make the nebulae stand out. So I can separate that little bit layer. I can come in and in one click sharpen all the dark nebula in a nebula like this and make it stand out. In fact, I've done that. So here is like this is a after. If you want to look at it, what it was, it's this guy. Okay, so this is before I do that. Okay, all right. This is, see how bright the stars are? This is how they are when I reduce them a little bit. Doesn't look like much, but it's really substantial. Okay, so now you see how this stuff here, it looks kind of sharp, right? But if I actually run, I run my nebula sharpener. I call it the nebula detail enhancer. And when you do it, look what you get. These dark nebulae are far more accentuated. And then what you do is you go and you reduce the brightness of the stars to compensate. It's really just a really interesting program. It's Photoshop CC for Creative Cloud, and it's actually, I actually subscribe to it. You know, so I pay like $10 a month to have Photoshop the latest and greatest. So anyway, maybe at some point, if you guys are interested, I will take you through a whole processing session so you can see where this comes from. To be honest, like the actual stacked images, they actually come from. Let me just show you how they look when you first get them. All right, when you first get these and bring them up. All right. Okay, like here, this one here is the beautiful Veil Nebula, right? So if I bring that guy up, that's a dumbbell. That was the wrong one. Sorry, I'm a dumbbell. Okay, but if I get the stack, if I get the Veil, all right, and bring it up, okay, so it's gotta be this guy. All right, so there's the Veil. That's what it looks like, unprocessed, right? But then I have a couple things that I wrote that actually allow us to just start pulling things out. Okay, here's one. Okay, and this one right here that I do already just starts to pull the detail out. See? Then I go in and I figure out a way to make the background the proper color. So I actually use this here and I do this. And then I do this and I drop it down. And you see how quick it's happening? So this is what happens. Then there's a bunch of things that happen after this. But if anyone's really interested, maybe we can start talking about this at some point. But it's fun. And it's what I do. And I've gotten to the point where it just doesn't take me any time at all to do it now. Especially since I wrote the actions. But and I'll make those actions available to people that want them as well. So that's not a problem. If you have Photoshop and you want these actions, and right now Isabella's going, what? You know, if she's even still listening.
She is.
Yeah. Yeah, Legacy, I'm interested, please. I know you are. Okay, they're only $150. No, I'm not charging for them. Hi, Laura Newbert. How are you? You just joined us. I hope you're not just joining us. Did you miss what we did tonight? Because we're just closing down. The roof is back on. See over here. Anyway, you guys, thank you for coming out. I really enjoyed your company. So did Daryl, I'm sure. He's been having a very spirited conversation with a whole bunch of you out there. That's fantastic. He's a font of knowledge and information.
Oh, please.
Oh, what, more? You need more? I can say more.
No.
That's all right. So anyway, you guys have a good night, and we will return on the next clear night, which could be as soon as tomorrow. You know, it's a big universe, and there's plenty to see. And we'll pick 3 more objects and go for them. So there we go. All right, guys. So I will see you later. And Daryl, thank you again for joining me. And I'm sorry that I neglected to announce you right away. I was just tied up trying to get that plate solve thing.
No worries.
Thanks, man.
You're welcome. Good night, everybody.
Good night, folks. You have a good night, and we'll talk to you possibly tomorrow. And don't worry, the monsoons have broken in Arizona. At least it appears that way. Got beautiful clear nights out there these last few days. And Daryl's even saying that the clear nights are coming for him in Colorado. So for him, I think you're losing the monsoon as well, right?
It's trying. I mean, it'll... we've had a week of sunny, hot weather, and then the rain came back tonight, and it's going to be back to hot and sunny tomorrow, but it's also cooling off a lot at night. And
okay.
It usually breaks about Labor Day, so next week.
Okay. I noticed the weather patterns changing out there, and we didn't have the benefit of the service that we use, windy.com, to check our weather. So Daryl and I made an educated guess about whether anything would happen, and I'm pretty sure nothing would have happened. I think we're okay. But with the moon up, I just want to show you on the all sky cam. This is only a 10-second shot. but you can actually see, when it comes up, see the moon's just rising over here. But look at the Milky Way. In 10 seconds, we get this beautiful Milky Way. That's Jupiter, and Saturn is it's over there somewhere. It's right there, I think.
Yes.
And then that's the ugly moon.
Right over to Jupiter.
Yeah, this is Jupiter here, and then we have Saturn right there, I believe.
Yes.
Yep. And there's the Sagittarius star cloud. Yep. This is a reflection, this thing here, that's actually from the moon. So is that. Yep. Well, there you go. So that's the kind of nights we're going to have, folks, and I hope you will learn to appreciate them as I do. You know.
Good night, everybody.
You guys have a good time. Have a good night, and we'll see you the next clear night. So, this is SkyTour LiveStream out for tonight. See you later.